Alright, test, 1, 2, test. Perfect. A bit late today due to technical difficulties, but in case any of you aren't aware, Elden Ring just released, I think 2 days ago. I've been looking forward to Elden Ring ever since the game got announced, and they finally released. The release wasn't that spectacular, it didn't flop as badly as some of the other games like Cyberpunk, but it did end up getting mixed reviews on Steam on day one. Most of the reviews that were negative was talking about performance issues, stuttering, games crashing, all that. Well, I don't know what to think about it. Probably hold off buying it until they fix everything. But that is perfect because maybe in a year it'll go on sale. And then I'll finally get the game. I don't think I'm gonna buy Elden Ring now. But to celebrate the release of Elden Ring and the start of school, we have something very special today, which is calculus. Anyway, today I'm gonna be doing what is a textbook called? Calculus, what, 8th edition? It's something 8th edition for calculus. And today we'll be doing a couple problems from lesson 6.1 all the way up to 6.3. So 6.1 is all about calculating an area using integrals. Specifically for number 7, we would need to calculate an area between two curves. Now the first thing probably want to do is draw a graph. Do I have any? Let me think. Let's try this. That's not working. Yeah, you know what? I'll just freehand it. Not like anybody actually uses a graph. But it is helpful that you have a graph. It doesn't need to be the graph doesn't need to be precise. It just needs to show whichever curve's on top, whichever one's on the bottom. So here we got x minus 2 squared. That's a parabola starting at x equals 2. It's kind of hard to draw on this thing. So this is where it's gonna start, and it goes up 1, right 1, up 1, right 1, and then up 3, left 1, up 3, right 1. So we have a parabola, and we have y equals x, which is a straight line, and that is very easy to draw, 45 degrees. Or rather, I can't draw straight lines. But there we go. Let's pretend that's a straight line. And then we want the area enclosed by the two curves, which is right here. To do that, you need to take the integral of the upper curve minus the lower curve. In our case, this is going to be the integral of x minus 2 squared dx. And the interval is going to be from where the two lines first intersect to when they intersect second. So that's going to be starting at x equals 1 up to x equals 4. Oops, let's not zoom in like that. Thank God. Oh, I can't move around it. Alright, that's fine. And then we get to the boring part, which is actually calculating the integral. This part's really tedious, especially we have to do it like 10 times over within an hour. But it's not really the hard part. So let's just first simplify a little. We'll get negative x squared minus 4x. We multiply that out, fold it out. and plus that x from here, we get plus 5x, and then minus 4. So we integrate to get the interval from 1 to 4 of negative 1/3 x cubed plus 5/2 x squared minus 4x. I'm gonna assume that anyone here already knows how to do the basic integrations. If I do use any trig identities, all that fun stuff, I will talk about it. But integrating, you basically raise a power by 1, divide by that power. That is the most basic way to integrate. And then you get to the even more tedious stuff, which is not even calculus, just straight up algebra now, where we get to plug everything in. So we get negative. I see a pattern here. So how about we call this negative 4/3, or rather, I shouldn't make it too confusing for everyone else. I'll do negative 1/3, 4 cubed, plus 5/2, 4 squared, minus 4 squared. Some of you might already notice that we can factor out 4 squared. And then we'll be left with negative 4/3 plus 5/2 minus 1. But of course, that's only half of the problem here, because we also need to subtract whenever we plug in 1. So we get negative 1/3 plus 5/2 minus 4. I hope that's right, because I tend to make a lot of mistakes with algebra. And if we simplify that as well, we would end up with... oh man, this does not look fun. Let's just do it... how should I put it? Let's do this a long way. If we simplify this... rather, let's do this one part at a time. We get 16 times... what? 2 times 4, 3 times 5, cross multiply, all that. And what does that equal to? My brain just stopped functioning. Get 15, get 8. That is negative... 15 over... oops, oh no. I forgot. Oh god, it did not save. This is bad. Uh-oh. Okay, good, it's saved. Wait, where is everything? Oh, here it is. There we go. Minus 8/6. So that's negative 7/3. No, over... I'm messing stuff up. This is what happens when we don't sleep for too long. So we get negative 7/3. Hang on, not negative. Give me a second, let me think about this. Why is this so hard? Gets... if we put the 1 in there, let's say negative 7/3 plus 5/2, we would end up with 1/6. And also, I don't have a calculator at this moment. So this is even more painful than normal. And if we do the same to this part, we get 3/2 minus 1/3, we'll end up with 9 to oh god, something is wrong with my math skills. So long we end up with 13 over 6 minus 4. Yeah, okay. Then what am I doing? I need a calculator somewhere. Excuse me for a moment. Go first off, messed up a little bit here. I can't flip the pen to erase. Okay, 16 over 6 minus 13 over 6 plus 4. You get 3 over 6 plus 4, which is equal to 1/2 plus 4, which is equal to 9 over 2. There we go. Can't believe I struggled so hard with the first problem. Alright, move on to the next problem. It's going to be number 11. Let's see, should I do this vertically or horizontally? Probably want to do this vertically. So get 8 here. Uh-oh, I'm writing too big. Think that's alright. 8, pixelated 8. Not 8, forget that. 11. We're not doing 8. X is equal to 1 minus y squared. And x is equal to y squared minus 1. Okay. This one is going to look a little weird because everything's in terms of y instead of in terms of x as it normally would be. But if you just take a closer look at it, it's basically two parabolas facing each other. So we're gonna have 1 and -1. One's gonna be facing this way. The other is gonna be facing the opposite way. If you're really not comfortable with doing this stuff where you have horizontal parabolas, you can just take the area of the inverse of those functions. So instead of x equals 1 minus y squared, we'll do, let's put this in red. Y equals 1 minus x squared and y equals x squared minus 1. It would turn your graph over by 90 degrees. It basically takes the inverse. I don't know if your teacher would accept it for work, but the resulting number you get at the very end will be the same. But we're gonna do this the normal way. So what I notice is that we have symmetry. Actually, we have 4 ways of symmetry. Because this part, this part, this part, this part are all the same. Which means this problem is even easier than it normally would be. We just need to take the area from 0 to 1 of area 1 here and multiply that by 4. Because all the other areas are equal. Do that, let's say this is, or either equation works, but let's say it's 1 minus y squared. We're just integrate 1 minus y squared dy. And let's see. That would turn out to be y minus 1 over 3 y to the third power from 0 to 1 times 4, which will lead us with 4 times 1 minus 1/3, which would in turn leave us at 4 times 2/3, which is 8 over 3. That's a slightly easier problem. All right. Now the answers to the odd numbered problems are actually in the book. So I'll be checking my answer from time to time if I'm not sure what my answer is, or if I'm not sure what the answer is. Or after, wait, no, it's not 13. We gotta do 15 is next. 15 looks like I'm gonna hate it because we got trig functions now. We get y equals secant squared x and y equals 8 cosine x. And this is gonna be between the intervals negative pi over 3 and pi over 3. So just because I don't think they're gonna give hard questions at number 15, I would guess that these two intersect at pi over 3, at x equals pi over 3 and negative pi over 3. So secant x, or rather secant squared x, is just 1 over cosine squared x. And because it's a squared function, it's going to be an even function. Cosine is an even function. So these are both even functions, which means two sides of the graph are going to be the same. If we do try to graph it, oh god, how do I graph secant squared? Secant squared would look something like this if I'm not mistaken. And it keeps going, but we were only interested in this one. So secant squared of pi over 3 would be 3 over 4. No, 4 over 3. And then we'll have 8 cosine of x. 8 cosine of x at pi over 3, that would be... Wait. Let me think about this again. Cosine of pi over 3 is 1/2. So at pi over 3, which is gonna, let's say it's right here, 8 cosine of x is going to be at 4. And it would have went down like this. Okay. So I don't have enough space up top. But it's gonna have an x or y intercept of 8. And this would be the area we need to find. And secant squared of, that's just, yeah, that's just 4. So it does intersect at pi over 3, 4. So that makes things easier. I'm going to use symmetry once again because they're both even functions. I'm going to go from 0 to pi over 3. And 8 cosine x is going to be the function on the top. So I have 8 cos x minus secant squared x dx. And when we integrate that, 8 cosine of x turns into 8 sine of x. And the integral of secant squared x is just going to be tangent x. That needs to go from 0 to pi over 3, and then we're going to multiply by 2 after. Scroll down a little. Now what comes next? We plug in pi over 3. 8 times pi over, or the sine of pi over 3 is going to be root 3 over 2. So we have 8 times root 3 over 2 minus tangent of sine pi over 3 over cosine pi over 3. That is going to be just root 3. And let's see. If we simplify that, we get 4 root 3 minus root 3. Of course, we need to multiply that by 2. So then we just get 6 root 3. Oops, let's see. Next question. Alright, let's box in the answer. I'm gonna try to box in every answer. Yeah, I did box in every answer. Next up is 17. We're getting all the odd number problems. That's good because I can check my answers if I'm not sure. Now we've got another one that's more dependent on the y-axis rather than the x-axis. Just to say it's a more confusing one. I think I just made it more confusing. Alright, by the looks of it, we got 2 horizontal parabolas. If you graph them like how you would on the x-axis, it's gonna basically be the same thing. Let's see, 1, 2, 1. Because that's 2y, we're gonna have it increase like that. And then it's gonna go all the way up to 8. But is that where it's gonna intersect? 1, 2, 3, 4, 5, 6, 7, 8. Let's say this one goes like this. Ah, my lines. So hard to draw curves. It has to be perfect. Come on. Why can't I do it? Let's pretend that's a perfect parabola. Now, 4 plus y squared. That means it's gonna start at 4. 1, 2, 3, 4. And then y squared normally. So it'd be 1, 1. Up 1, right 1, down 1, right 1, and then up 1, right 3, which is perfectly going to match here. Fantastic. And what do I notice again? The 2 halves are symmetric. So that means we just gotta take the integral from 0 to 2, that's right here, and multiply by 2. It's gonna give us the area of the other half as well. The curve that's on top is going to be 2y squared, and the equation on the bottom is 4 plus y squared. And parentheses, of course, dy with respect to y. Now then, I might need to do this 2 times, do I? Might have to do this twice. Actually, no, I don't, because this is with respect to y. You only need to do with one integral. So let's integrate that. Okay, integral of 2 to 2 simplified a bit. 2y minus y squared, that's y squared minus 4. Okay, doesn't look too bad. If we integrate that, we get 0 to 2 of 1 over 3 y cubed plus, no, minus 4y. Move it up a little. And let the graph still be visible. Plug everything in, we get 2 to the power of 3. Doesn't look right. Something is wrong. Okay. 8 over 3 minus 8 is negative, which means the answer is not that, in fact. Oh yeah, I messed up the order a little. Now, if I just keep finishing this and take the absolute value, I'll get the same answer. But I will correct the error. The problem was because this was in respect to y. This is higher, this is lower. Which means that the equation or the line on top is actually 4 plus y squared. So get 4 plus y squared minus 2y squared. And now that's what we want. We do the exact same thing, takes the integral, we get 4y minus 1/3 y cubed. See, if I continued earlier and just taken the absolute value, I would have arrived at the same answer by the end. However, this would be the correct work shown, despite getting the same answer. Now if we just plug everything in, we get 8 minus 8 over 3 times 2. So we get 16 over 3 times 2. We get 32 over 3. Alright. Next up is... which one did we just did 17. Next up is 21. Oops. 21. Can't wait to zoom out and just realize my entire thing's been slanted. Oh wait, it's actually pretty straight so far. I'm surprised. Alright, let's zoom in a little more. 21 says, trig functions again. I hate these. Y equals tangent of x. And y equals 2 sine of x. And negative pi over 3 less than x less than equal to pi over 3. Hang on. That feels pretty similar to the other one. Okay. This will be quite difficult to graph. Tangent function looks like this. We really only care about the first one. It would go on forever like that too, but we really only care about the one in the middle because of this thing here. So sine of x would normally look like this. That does not look like a sine. It will look like this. But because it's 2 times sine of x, it would probably go over the tangent one. Like that. Oops, let's draw a little better. That would be what it looks like. And what do I notice? Tangent is an odd function. Sine is an odd function. They're both odd functions. We can use symmetry once again. I am going to assume that tangent of x and 2 sine of x intercept at pi over 3. And let's actually test it out. That's root 3. Sine of x, sine of pi over 3 is root 3 over 2 times 2 root 3. Yes. This is perfect. And sine of x, we're taking the integral with respect to x. Therefore, 2 sine of x is the one on top. Minus tangent of x. And dx. Now then, we just gotta integrate. I can't wait to forget about a negative sign when integrating one of these things. Anyways. Can't simplify any further. 2 times 0 pi over 3 of should be negative 2 cosine of x. Right? Because derivative of cosine is negative sine. And then tangent, which should be secant squared. Right, hang on. Give me a second. Nope. I remember the wrong one. That's a derivative. The integral of tangent of x is natural log of secant of x. And now we're going to plug everything in. Negative 2 cosine of pi over 3, that's 1/2. So negative 2 times 1/2, we get negative 1. Minus natural log of secant of pi over 3 is 2. So minus natural log of 2. Then minus 0. 2 negative 2 cosine of 0, negative 2. Oh my god, so much negative signs. And then secant of 0, that's 1 over cosine of 0, that's just 1. So natural log of 1. Hang on. Natural log of 1 is 0. How many negative signs did I mess up? And also we multiply the entire thing by 2. I need to double check this answer. So we get 2 turns to 1 minus natural log of 2 times 2. You get 2 minus 2 natural log of 2. Now let me check. That is in fact the correct answer. This happens all the time. I solve a problem and then I panic because I think I missed the negative sign. But I didn't miss a negative sign. Or after 21 comes 23. 23 says we want the area between the curves y equals cube root of 2x. Oh no, I hate this already. Y equals 1 over 8x squared. And between 0 and 6. Oh, how am I gonna graph this? Cube root would look like this. So cube root of 2x will look pretty similar. 1 over 8 x squared. That would look like this. All right. Let me try drawing that again. No! Let me draw it properly. Alright, this is the best I can do. And we want the area right here. I'm gonna assume that this is 6. And let's test that out. Oh god. Root 3 of 6? I'm sorry? No. That can be it. They cannot intersect at 6. Can they? We got 12. You can't take the cube root of 12. So 6 is somewhere here as well. We're gonna say this is 6. I sure hope this is how it looks. And let's actually solve for... Let's solve for the intersection point first. If we cube both sides, 2x equals... Oh god, 1 over 8 cubed times x to the 6th power. Is that it? Yeah. And if we divide x from both sides, this is how I solve it. Get 2 equals, or let's do 2 times 8 cubed equals x to the 5th power. X to the 5th power is equal to, oh my god. I really want a calculator right now. Is equal to, yeah. Let me just calculate this. We'll do 4. And can I... Give me a second. Can I take the root of this? Why is it so hard to use? Yeah, there we go. Not as bad as I thought. X equals to 4. This was solved using a calculator. I probably should know the 5th root of 1024. Should have known it's a multiple of 2. But now we know that the two lines intersect at x equals 4. So this is the most complicated problem we have so far because we need 2 integrals. One from 0 to 4 and one from 4 to 6. The one from 0 to 4 is going to be having the cube root on top. If you wonder how I knew which was going to be on top, I just guessed because over here, the cube root is going to be concave down, while the parabola is going to be concave up. That means the one that's concave down is probably on top. So we get cube root of 2x. Let me do this better. Cube root of 2x minus 1 over 8 of x squared plus the integral from 4 to 6. So that's this part right here, this little part of 1 over 8 x squared plus the cube root of 2x. And let's not forget the dx. Oh, and now we get to the fun part. Integral 0 to 4 of this is 2x to the 1/3. If you want to rewrite that, 2x to the power of 1/3. That means we get 3/4, or rather 3/2x to the power of 4/3 minus 1/24x to the power of 3. Then we plus, kind of the exact same thing, but the other way around, 1/24 times x to the power 3 minus 3/2 x to the power 4/3. At this point, you're better off using a calculator. But yeah, we're better off using a calculator. So 4 to the power of 4/3 times 3 divided by 2 is in fact not a perfect number. If we write this out first, 3/2 times 4 to the power of 4/3 minus, keeps feeling like there's another step I could have taken first, minus 1/24 of 4 to the power of 3 plus what is this? 6 to the power 1/24 times 6 to the power of 3 minus 3/2 6 to the power of 4/3. But then we would have the minus 1/24 of 4 to the power 3 minus 3/2 times 4 to the power 4/3, which isn't that the same as this part, but pretty much exactly the same. Which means we would get, no, this is problem 23. This does not look good. Oh my god, I can't even start putting my hand on this. 2 times 3/2, 4 to the power 4/3 minus, oh, we can simplify this a little bit. If we factor 1/4 out, we get 1/6. Or rather, factor all of them out, or 6 times 16, we can dump that down to minus 8/3. There we go. That looks slightly cleaner. Plus, you factor 1/6 out, we get 1/4 times 36. 1/4 times 36, and we can, that is equal to 9. Okay, that looks clean. Minus 3/2 times 6 to the power of 4/3. I've never felt so sleepy in my life of not sleeping. Alright, what's next? Imagine if I did a step wrong here and I just need to redo the entire thing. If I did all this for nothing. Hit 2 times. Here comes the hard part. 4 to the power of 4. 64. 256. We get 3 over 2 of 256. Can I simplify that? Let's see, is there a cube root of 256? No. Yeah, if we do this smart way, can I do 256 divided by 8? Should be able to. That will leave us with 32. So we can factor out 2 8s. That means we'll get a 2 out. And another 2 out. Let me do a little more calculator. All right. This would leave us with 4 root 4. Rather 4 cube root 4. So that would be 6 cube root 4. Minus 8 over 3. Okay, that's half of it done with plus 9 minus. And we got another one of these nightmares. Same thing, calculator time. 6 to the power of 4. Can I do 4/3? Is that a thing? No, it's not. Of course it's not. It's never going to be that easy. Can we divide that by 8? And divide that by 8. We could do it once. This is a nightmare. Let's see this. How about 27? Oh, we can do it by 27 and then by 8. So that would be 6 root 6. Wait a minute. So would 5 root 5, or rather, would 5 to the power of 4 over 3 just be 5 root 5? Is that how it works? Now I need to find out. I need to know. Did I find a glitch in the matrix? Oh my god, it is. It is. I just discovered something. Wait, actually. Oh, welcome back, Solo Levels. We just discovered a loophole in the matrix in that x to the power of 4 over 3 is equal to x squared root of x. So that feels like something I should have known. Yeah, I'm not gonna dig too deep into that. I'll leave that as a debate for another day. The good thing is we have our answer here. Don't worry, we're almost a third of the way done. We have all the time in the world today. And tomorrow. There is no sleep if you don't complete your math homework. Anyways, now we get to deal with this nightmare. Oops, I should not have done that. 2 times 6, that's 12. 3 or 4 minus 8 over 3. I have a feeling I did this entire thing wrong. If you just try one of these problems, you're pretty much guaranteed to fall asleep within 5 minutes. If you can survive that long. That's a big if there. And then we add 9 minus 6 root 6. Yeah, this answer feels wrong. Feels like it just did something really dumb. Aside from maybe that's a cube root. You know what? I'm gonna do this the brute force way. I'm gonna check the answer key because if this is wrong, I don't want to continue doing this. The answer key has all the answers really neatly simplified. That turns out to be about 5.36 would be the correct answer. And my monstrosity over here. Here's the thing, when you're doing calculus, it's more about the work you do along the way rather than the answer. It's like how in One Piece, it was the real treasure was the friends you made along the way. In calculus, the real treasure is the work you do along the way. Because while I can do calculus, I am really not good at algebra. It's 12 times 4 to the power of 1 over 3. Hey, the answer key's in the book. If they gave me the book, I will read it. I will read every page in it. And oh my god, Google does not want to solve this problem. And yeah, we have the wrong answer. Here we have the absolutely wrong answer. I think the first problem I made was right over here when I forgot there was a 2 in here. Ah, I forgot that there was a 2 in here. Wait, did I? Let's try that again. Okay. Yes, thank you for dropping by to say hi. I hope you get your sleep soon. If it's already 6 a.m., I hope you have a good dream. You can leave this nightmare now. Anyways, where was I? Alright. Have a sweet dream. Integrate 2x to the power 1/3. I don't think I made a mistake there. But the problem could also be with my integral itself. So let me double check on that. Mm. 2x to the power of 1/3 minus 1/8 times x squared. Huh. Between the 4 and 0. Between 4 and 6. From the looks of it, my integrals are correct. My integrals are correct. But then I did something wrong in algebra. Algebra is honestly the worst part of math. Alright, let's try that again. From 0 to 4 of... That's 2x 1/3. So we have x to the power of 4/3 and 3/2. If we differentiate that, we will get 4/3 times 3/2. We get 2x to the power 1/3 would be correct. And then we subtract from 1/8. No, we need to divide by 3, so 24. 3 times 8 is 24. X cubed. And would we actually be able to simplify that a bit? Let's see, if we factor out an x, if we factor out about half x, we get 3 root 3x minus 1/12 x squared. As we factored out 1/12 of it. We factor out another 3. Wait. I see where my problem lies. The 2 is inside. The 2 is inside the radical. I forgot to put parentheses here. Oh my god. Okay. 0, 4, 2x. Forward straight. If we differentiate that, we would need 8. And just to double check, because I haven't done this in what, 2 years? 4/3, that's 1/2, 2x, 1/3, and then 2. Alright, I think that's it. Minus 1/24 x cubed. No problem with that. Still can't believe I made such a basic mistake again. That means we can factor out... What can we factor out? Huh. Factoring out maybe 1/8x first. So we get 3 times the cube root of 2x minus 1/3 x squared. Or rather, I think there's an easier way about this. Hang on. What if we take 2 to the power, rather, we can rewrite that as square root of 3 square root cube root of 2 times cube root of x minus 1/8x squared. Can't really factor anything out here. What I can do is this thing stays, and then we get does this stay? I'm confusing myself now. This is definitely negative 1/24x squared. But this would turn out to be what would this turn out to be? If we just integrate the cube root of x, that is 3/4 x to the power 4/3. And then we just add or to the power 1/3. Huh. How does this work? Why is it so confusing? Okay, I need to check this. There's nothing wrong so far. 2/4. Yes, 2/4 times x to the power 4/3. That part's correct. But how do you get from the cube root of 3 times 3/4x? Actually, let me rewrite this as a power to the power 1/3 times 0/4x to the power 4/3. That's 2 to the power 1/3 times 2 to the power of -2 times 3x times 4/3. Which means now it's 2 to the power of -5/2 times 3x to the power 4/3. And then you can get to 3x 4/3 divided by 2 to the power of... Let's write this as a coefficient. 3 over 2 to the power 5/2. Wait. Over 3. Why did I write 2? Almost made another basic mistake there. 5/3 times x to the power 4/3. Now that is how it's actually done. Alright. Let me actually move this a bit. Do a lasso select. Just move it up here a little bit. That's fine. Now we need that from 0 to 4. And then from 4 to 6. 46 of the other one. Or you could just say minus 46 of this. Well, let's write this a proper way since we already spent so much time on this singular question that it's more than the rest of the questions combined. 1/24 x squared. Did I just write x squared squared? And that's a plus. Minus 3 over 2 to the power of 5/2 x to the power 4/3. Oh God, save me. So that's 3 over 2 to the power 5/3 times 4/4 minus 2, no, 4/6, that's 2/3 plus, let's see, 6 3/2 minus 3 over 2 to the power 2, 5/3. That's a 3. Why do I keep writing 2's? 3. And then times 6 square root of 6. Hang on a second. cube root. I'm actually falling asleep here. I thought that would never happen. I never thought there'd be a day where I could fall to sleep. And then we just do all that again. This is basically the same as this, but flipped. 4 and there. So what we end up with is 2 times whatever this is. I'm not even gonna try now. Times 4 cube root 4 minus 2/3 plus 3/2 minus whatever this thing is. 6 cube root 6. I'm gonna try that again. I'm gonna try to put that in the calculator again. If I did everything correctly, if I didn't make another mistake somewhere, this should be the right answer. Let's just call this 4 to the power of 4 over 3. Minus 2 over 3. Plus 3 over 2. Minus this eldritch horror. Times 6, or rather 6 to the power of 4 over 3. Is in fact not correct. But the first half is correct. Or is it? No, there's been another mistake here somewhere. I hate this one problem in particular. If everything is correct, the first integral should evaluate to 10 over 3. Hang on. The first integral should evaluate to 10 over 3. And the second integral is a mess. If I just take a look at this. One over 24. Did I write x squared? Yeah, I just made another typo and that ruins the entire problem. That should have been x cubed, not x squared. Why did I write x squared? If we do that, this would be minus times another 4, 8 over 3. That's an 8 now, because I said so. This is also 8. And this would be times another 6. That would be a 9. And then it would be and then it would be the correct answer. There we go. Now I'm gonna simplify it. Just trust me and my calculator. This is your correct answer. Actually, we could simplify that just a bit. We could turn that into 3 over 2 to the power of 5 over 3 times 4 cube root of 4 minus 8 over 3. Just make it cleaner. Plus 9 minus all this stuff. Never want to see that again. Times 6. All that. Multiplied by 2. And there you go. Just trust me, that is your answer. I do not wish to simplify it any further. But if you do want the simplified version, I don't know how they did it. And I don't want to try because that's going to spend way too much time and I'm going to make another dumb mistake. This is the simplified version. If you calculate them in the calculator, you come out to the same number. But I do not want to simplify. So you have to bear with this answer. Alright, finally we should have problem 27. 27 says... 27 looks like it's another complicated one. Alright. Equations first. We got the area between y equals 1 over x and y equals x and y equals 1 over 4x where x is greater than 0. That means we only need the first quadrant. But let's do this just in case. So y equals 1 over x. That's pretty easy. Looks like that. Let's get my blue pen. Looks like that. Y equals x. We got a diagonal line going through. And the y equals 1 over 4x. We got a... Oh. And we want this area here. That means we are going to need, in fact, 2 integrals. The first integral would be right here where these two lines intersect, which is going to be at 1, 1. So we have the integral from 0 to 1 of the top line is x minus 1 over x. And then we get 1 over 4x equals 1 over x. X equals 2. So we got from 1 to 2. Looks pretty clean so far. Of the top one is 1 over x minus 1 over 4 times x dx. Then we integrate. We get 0 to 1 of 1/2 x squared minus natural log of x. Integral of 1 over x is natural log of x plus from 1 to 2 of natural log of x minus 1 over 8 x squared. Okay, now we plug things in. We got 1 over 2. 1 over 1 over 2 minus natural log of 1 is 0. So we minus 0, 0. Natural log of 0 is negative infinity. I'm having second thoughts. 1/2 should be it now. And then we have or plus natural log of 2. Can't simplify that. Minus 1/2 minus natural log of 1 is 0 minus 1/8. Is that it? I am getting stuck again. Let's see. Where did the first mistake come into play? Probably this part. X. Oh, I see what the problem is. The bottom line for both of these is 1 over 4x. So this is the right solution. So I could have written this better. I should have said, you know what, forget it. Could have simplified that to 3 over 4x first. But this will do just fine. We got 1 over 2 minus 1 over 8. So that should be 3 over 8. Or rather, let's just write this a short way. Because that is going to be equals to 3 over 4x. This is just going to be 3 over 8x squared. So that's going to turn out to be 3 over 8 plus natural log of 2 minus 1/2 minus natural log 1 is nothing minus 1 over 8. That's going to turn out to be 4 over 8. This is going to turn into positive 1 over 8. Add it together. That's going to be 1/2. And it cancels out neatly, leaving us with natural log of 2. We have a clean answer like that. It's usually the right answer. All right. That was way longer than I expected, but that concludes lesson 6.1. I'm gonna create another column here called 6.2. 6.2 is all about volumes using cross sections. And we will be back after this quick commercial. All right, welcome back. And everything's set up. First question of 6.2 is going to be number 1. And let me quickly go over volumes with cross sections. I would say these problems are a bit harder, but not as time consuming as some of the other problems where you just need to integrate. So let's say we have, we want the volume of rotating a shape bound by the constraints y equals x plus 1, y equals 0, x equals 0, and x equals 2, rotated about the x-axis. And if we draw a graph of that, it looks like this. 1, 2, 3. 1, 2. Oops. Straight line, come on. Give me a straight line. I can never draw straight lines. That is the best I can do. And what we'll basically do is we rotate the shape around the x-axis to make a shape that looks like this, or rather we make a volume that looks like this. Where this is the x-axis. We rotate it. So below here, it would just look like this. If we rotate it, get a cone, kind of like a cone with a cut-off tip. The point of solving using cross-section, or rather the formula, I would say, is we take the sum of all the cross sections. A cross section is any one moment, or rather any one instant, any one area that happens when we cut a shape in half. So we cut that in half, we get a circle. The cross section of everything here is a circle. So let's say this is A, this is B. We start at A, end at B. We would take the sum of all the areas here. Oh. We take the integral of every single cross section. And because our cross sections are circles here, this would look like pi r squared. Should I put it that way? Pi radius squared. Because area of a circle is pi r squared. And if we actually plug in our numbers from 0 to 2, we get something like pi and our radius, which is going to be x plus 1 squared. X plus 1 being this line here, that is a radius of a circle, or rather the radius of any cross section of or cone-like shape. And then the height, which is going to be dx. It's a cross section, it doesn't have any thickness, it doesn't have any height. It's just dx. It's infinitely thin, it's infinitely small. And we can take any constant outside And thus turning this to pi, and the integral from 0 to 2 of x plus 1 squared dx. And then you just have to solve the integral and you're done. So now you get to the tedious part. We get pi, integral from 0 to 2 of x squared plus 2x plus 1 dx. Keep solving, get pi and sum of 0 to 2 of 1/3 x cubed plus x squared plus x. And you solve that, get pi times 8/3 plus 4 plus 2. And that would mean you get... oh no, not algebra again. 6 26/3 26/3 pi. Is that right? Feels right. All right. So now on to the next question, which is going to be, we're making the jump all the way to number 9, which is going to be the area between y squared equals x and x equals 2y rotated about the y-axis. So we're rotating on different axes this time. Of course, just like always, let's draw a graph first. Do my best to draw straight lines. It's never going to be straight, you just gotta deal with it. And x equals y squared is going to be a horizontal parabola. Kind of like that. It's incredibly difficult to draw curves like this. And then we got x equals 2y, which is going to be y equals 1/2 x. So it's a line with a slope of 0.5, kind of like that. It's going to intersect that x equals 4, y equals 2. And this time we're rotating around the y-axis. That means our shape would end up here. So the shape we would get will look kind of like that. Just imagine you rotate that around 360 like a funnel. It looks like a funnel. Can I draw a funnel? No, I can't draw a funnel. Okay. So we rotate this area around across the y-axis. And because we're rotating across the y-axis, we gotta do everything in respect to y instead of x. And this time our cross sections are not going to be circles. They're going to be circles with holes. And because they're circles with holes, we need to take the holes out. We get pi, big R, and this is there's big R and small r, let's say that. Pi r squared minus pi small r squared. That way we just get the area of the donut without the hole. And to do that, we would simply put it in integral again. With this, we can actually factor out pi times r, big R minus small r squared, like that. And we just gotta put that into another integral. That's all we gotta do. Because we're doing with respect to y, we go from 0 to 2. That's the height of from 0 to 2 on the y-axis. On the x-axis it's 4, yeah, but this with respect to y. We do the same thing. We can take the pi out because it's a constant. It doesn't need to stay in the integral. And then we need our big R. That's the outer radius. The outer radius is defined by the line 2y. So we get 2y squared minus or smaller, which is our parabola, minus y squared squared, which is y to the power of 4. dy, no longer dx, we're doing dy now. Whereas I should put this in parentheses too, just so it doesn't get confusing. So now if we just simplify this a little, can probably skip a step here if you want. We get 4y squared minus y4 dy. And simply integrate that. We get 4 over 3 y cubed minus 1 over 5 y to the power of 5. Plug in your numbers. Pi times 8 times 4, 32 over 3 minus 32 over 5. By the looks of it, if we multiply that out, that turns out to be, okay, 64 pi over 3. Our answer is going to be, no, what am I saying? Or 15, because 3 times 5. And there we go. That was a relatively easy one. Next up is going to be question 11, which asks cross area rotated by y equals x squared. Hang on. X equals y squared about y equals 1. So we're not even rotating against the x or y axes. We're rotating against y equals 1. Let's draw a graph for that. So we have one normal parabola and one cursed parabola. We want to rotate this area about y equals 1. This is y equals 1. This is 1 now because I said it is. So this area rotate this way. And that would give us another funnel. Now, same thing here. The cross section is a donut. The outer radius is defined by this line right here, because it's further away from our axis of rotation, which is y equals 1. And because we're rotating... Wait, no. My bad. I saw it said x equals 1. We're rotating against this line. Just give me a straight line for once, please. Okay, we're gonna. How do I do this? Straight. Okay, straight enough. We're rotating against this line, which gives us another funnel, kind of funnel-like shape. We're rotating here. Our cross-section given like that. If we draw a cross-section, there's our donut. Big R, small r. Big R is on the outside here, small r is on the inside here. I'd probably do better if I zoom in a little. Why is it lagging? Anyways, there's our terrible graph, but it gives us enough information to know which line's going to be on top. We're rotated against y equals 1. So our cross sections are perpendicular to x. That means, just like we did in the first problem, everything's going to be in respect to x. So we want to solve for y. If we solve for y here, we get y equals the square root of x. It should be plus or minus square root of x. But we really only care about the top, so we don't need to care about plus or minus for now. And let's do our integral from 0 to 1, because these two parabolas will intersect at 1, 1. And we want to pi out here, because we simplify it out. And then take our big R. The big radius is the distance from the line y equals 1 to the parabola y equals x squared. That means we gotta take 1 minus x squared. That's our big R, big radius. And let me do a better parentheses than that. Then subtract our small radius, which is the distance from y equals 1 to y equals square root of x. So let's do 1 minus square root of x squared dx. And now we get back to algebra. Calculus is 80% algebra. From 0 to 1, pi, blah, blah, blah. We get 1 minus 2x squared plus x to the power 4 minus 1 minus 2 square root of x plus x dx. Simplify that out. That turns out to be x to the power 4 minus 2x to the power of 2 minus x plus 2 square root of x, and then the 1's cancel out. To make it cleaner, let's say x to the power 1/2 instead, so it's easier to integrate. Now then, we simply need to do our integral. Take the integral, and it turns out to be 1 over 5 x to the power of 5 minus 2 over 3 to the power, x to the power of 3 minus 1/2 x squared, and I didn't mess up any negatives, did I? Plus 4 over 3 x to the power of 3 over 2. So luckily our number here is 1s and 0, so we simply need to add together the coefficients. That turns out to be 1 over 5 minus 2 over 3 minus 1 over 2 plus 4 over 3 pi, which is going to evaluate to or 5 minus plus 2 over 3 minus 1/2. Oh my god, none of these are multiples of each other. That turns out to be 15, 3 plus 10, 13 13 out of 15 minus, let's see, 26 out of 30 minus 15 out of 30 turns out to be 11 out of 30 pi. Seems that way. Let's write this cleaner. 11 pi out of 3. No, 30. There we go. Ooh, another one done. That was number 11. Next up is going to be number 14. Number 14 wants the volume of the shape rotated using y equals sine of x, y equals cosine of x between 0 and pi over 4 about y equals -1. Okay, I remember doing a question kind of like this in class, so this is gonna be an easy one to deal with. And I just realized there's a ruler. How do I rotate the ruler? Whoa. Can I rotate the ruler, please? I don't know if I can. But whoa. It's an actual ruler. Why am I so excited by a ruler? Anyways, you already know what sine and cosine looks like by now. Sine goes like that. Cosine goes weird like that. And it keeps going. This is not an accurate graph. But if we go between this here is going to be pi over 4. So the area enclosed is right here. And we want to rotate about y equals -1. This is -1. So we want to take the cross section here. And if we rotate it, it's going to go all the way down here. If we rotate it across around this axis, let's go all the way down here, and we have our little donut thing. That is not how it will look like. But while this graph is terrible, give us sufficient information that the radius further away from our axis of rotation is the top one, which is going to be cosine. That means we simply need to take the integral from 0 to pi over 4. Cosine on top. And here, because we're actually 1 away from the x-axis, we need to add that 1 back in. So we have cosine of x plus 1 squared. Because our radius is 1 bigger than normally if we would have rotated around the x-axis. And then we subtract sine squared x plus 1. And we take the integral. Actually, I made a small mistake here. There should be a squared here. Squared goes outside. But now we need a little bit of algebra again. Algebra and trig, the majority of calculus. And to do that, we just do FOIL cosine squared x plus 2 cosine of x plus 1 minus sine squared of x plus 2 sine x plus 1. And we do need to take the integral still. I'm running out of space. There we go. Now after you've done that, you can start doing a little bit more simplifying. Write out our integral. And let's actually organize this a bit. Cosine of x minus sine squared of x plus 2 cosine of x minus 2 sine of x. And then the 1 cancels out. If you take a look, cosine of x, rather, cosine squared x minus sine squared x. That is in fact the trig identity. And that can turn into cosine of 2x plus 2 cosine of x minus 2 sine of x dx. Now we can actually take the integral, which is in fact not that hard for trig functions. 2 cosine of x, that turns into 1/2 sine of x. Or rather 1/2 sine of 2x plus 2 sine x plus cosine of x. Plus 2 cosine of x, sorry. And then cosine and sine of pi over 4 are both root 2 over 2. So sine pi over 2 is going to be 1. We get pi times 1/2 plus root 2 over 2 times 2 root 2 plus root 2. So then we get pi times 1/2 plus 2 root 2. Can I simplify that further? Actually, wait a second. Sine pi over 2. I might be confusing myself again. And this is an even number question. I can't even check my answer. I shouldn't have anything wrong here. Sine of pi over 2 is 1 times 1/2. Yeah, why not? Let's call this. Won't bother simplifying further. But now for the rest of the day, I'm going to be questioning whether or not I did this problem right. Whoa, we're almost halfway through. Number 15. Was about to do the meme right there. Number 15, y equals x cubed. Y equals 0. X equals 1. About x equals 2. Alright. This one doesn't seem too complicated. We have a pretty straightforward graph. A cube looks like that. and one between x equals 1. So the area right here rotated across x equals 2. Rotate across this axis, it flips over, looks like that. And that's our cross section. I am going to speed through this one. I take the integral from 0 to 1 of hang on a second. We need to do this in respect to y. That means we need to do that. Okay. Yeah, of course it's not going to be that easy. You get the integral of... To get the integral of that area, we need... one minus... No. Might be thinking about this the wrong way. Y minus cube root of y plus 1 squared. Wait, no. Yeah, I was thinking about it too much. The big radius simply cube root of y plus 1 squared minus 1 squared dy. And of course we need our pi. That means we get y to the power of 2 over 3 plus 2y to the power of 1 over 3 plus 1 minus 1. And if we integrate that, we get 2 over 4 y to the power... No. 2 over 5 y to the power of 5 over 3 plus 3 over 2 y to the power of 4 over 3. Looks about right. Then we just get pi times 3 over 5. We calculate it out, plus 3 over 2, which, feels like I missed something again. What did I miss? It is from 0 to 1. The small radius is 1 always. Alright, there would have been 2 minus 1. Huh. Let's see. 2. Oh, that's 1. That's 1. Strange. I'm going to double check real quick. Give me a minute. Maybe 3 over 5. Hmm. Oh god, I can't think at all now. Wait. Two minus root 3. Why write plus 1? It's always little mistakes like this. Make one mistake, your entire problem is ruined. Hang on. Yeah, I almost made a huge mistake right there. So we will get 4 minus 4y to the power 1/3 plus y to the power of 2/3 minus 1. Integrate that. You get 3 minus 3y to the power of 4/3 plus 2 over 5y to the power of 5 over 3. So we get pi times 3 minus 3 plus 3 over 5. Wait, that's 3x. No, not 3x, 3y. And that cancels out, and we're left with 3 pi over 5. That is the correct answer. And then we're on to number what? 17. Wants the volume rotated between x equals y squared, x equals 1 minus y squared, about x equals 3. So that's 2 horizontal parabolas right there. One will look like this. The other one would look like this. And if y squared equals 1 minus y squared, then y squared equals 1, y equals square root of 1/2. No. Y equals root 2/2. That is a better way to write it. And I notice I can use symmetry here, but want to rotate against the line x equals 3. Rotate against here, we would get another shape over here that looks like that. Rotate across this axis. This one doesn't look too bad. I know the top and bottom half of this volume is going to be identical, therefore I'm going to use symmetry to factor out the 2 right there and simply go from 0 to root 2/2. That's where the 2 parabolas will intersect up here on the y-axis. The top one's going to be, or rather the outer radius will be 3. That's our axis of rotation. Minus y squared. And it's going to be minus 3 minus or 1 minus y squared. Squared. Oh my god, the parentheses are getting out of hand. And if you factor that out, I don't wanna. I wish there was an option to do calculus without algebra. Zero root 2/2, write that out. Whew. There should be squares there. Let's write that again. 3 minus y squared minus 3 minus 1. 2 plus y squared squared. Let's see. Looks okay. Now we have to factor 9 minus 6 y squared plus y to the power 4 minus 4 plus 4y squared plus y to the power 4. Simplify and we get 5 minus 2y squared dy. Now we actually do the factor, no, we actually take the integral. The 5x minus 2/3 x to the power 3. And the whiteboard is getting really laggy now. Ow. Ouch. Okay, 2 pi times 5 root 2/2 minus this is root 2/2. minus 2 over 3 root 2 over 2 to the power of 3. That's 2 root 2 over 8. Or factor that out to 4. And 2 times 2 for 12. Square root 2 over 2. Maybe do a little better than that. Ten root 2 over 2 minus, oh god, what am I doing? And that's 1/3. Forward tells 1/3. So if we multiply that by 3 as well, we get 14 over 3 root 2 over 2 and then times 2. Looks like I did something wrong. That part's fine. This is this part. Or did I forget another negative sign somewhere? Uh, 5 over 2 minus, we square that, that's 1/2. 2 over 6, so that's 1/3 root 2 over 2. The 5 minus 1/3 root 2 pi. But that doesn't seem right. Let's see, where did it go wrong? Every single problem has to go wrong at least once. Right answer should be should be 10 root 2 times pi over 3. This is definitely not it. Oops. If you look back at the integral, y goes root 2 over 2. Where did things start going wrong? I wonder. I've not found it yet. Outer ring's 3 minus y squared. Inner ring's that. Alright. It's time to bring out the calculator. About 14. The integral is correct. That means I made another algebraic problem. Where did it go wrong? Everything's set up correctly. Problems here somewhere. Here's it's definitely just going wrong. This is probably wrong as well. Okay. Nine minus 6. Five y minus looks like this is where the problem begins. Need from 0 to square root 2 over 2. And I see what my problem is. This is a minus sign. This is the entire time. The problem is that I added instead of subtracted. This feels almost like programming, where you spend 5 minutes writing code and 15 minutes finding a bug. And if we just do this, now everything's gonna work out perfectly to the correct answer. And if you solve for that, is that right? Theoretically, nothing to stop me from working now. If we simplify the 2 out, you get pi times 5 minus 5, or the 5 roots 2 times 5 over 3 root 2. And that perfectly goes into 10 root 2, 10 pi root 2 over 3. There we go. The entire problem was I added instead of subtracted 4. Oh, the lag again. That one tiny problem costed like 10 minutes. All right, now that's over with. The next question is going to be... Ooh, we're about halfway done. Question 33, which is actually into 2 parts. X squared plus 4y squared is equal to 4. And A, we want to rotate about y equals 2. B, we want to rotate about x equals 2. How long has this been? Okay, it's already surpassed the first chapter. So we'll draw a graph first. Okay, this is what do you call it? An ellipse. Oh, hello, George. This basically is calculus homework. It is a nightmare after all. So on the x-axis, we're gonna have it at 2. On the y-axis, it's gonna be in at 1. Let's make a bigger scale. It looks like... Come on. Just slowly, don't mess this up. It looks like a... Ah, darn it. It's fine, okay, I can still save this. It looks like a football. And want to rotate against y equals 2 and x equals 2. So how can I approach this? I know there's going to be symmetry. All we need to do is set up the integral. This one, the calculator is allowed. So once I get the integral up, I'm just gonna straight up calculate it. About y equals 2 first. We can go from 0 to 2 on the x-axis because 0 to negative 2 is just gonna be the same. It's symmetric. We get 2 pi over here. Let's solve for y. I believe we would need to solve for y first. Y is equal to 4 minus x squared divided by 4, taking the square root of. How can I simplify this? Or is there a need to simplify at all? No, let's simplify this a bit. This is equal to the square root of 1 minus x squared over 4. Good enough. Alright. So next up, we want this cross section, which the outer shell is going to be negative this thing squared, which is going to be just be positive. Oops. Minus that doesn't look right. Is my integral right? My brain has already ceased to function. 2 minus, or in this case 2 plus, one minus x squared over 4 squared minus 2 minus 1 minus x squared over 4 squared dx. Double check to make sure. This would cancel out pretty well. But if I don't have to simplify it, I'm not gonna simplify it. I'm gonna dump this one straight into the calculator. And from 0 to 2. Go. Oh, that looks ugly. Oh, I typed it wrong. Oh, that's right. Come on, give me the decimals. Oh, 4 pi. That's a clean answer. Then 8 pi squared. 8 pi squared is... Let's write down the answer. 78. We need 5 decimal places, so 9, 5, 6, 8. Do I round? Yeah, let's round. 4. So there you go. Big, ugly integral and some decimal. Anyway, that's part A. Still need to take care of part B here. But part B basically the same thing. Except we have to do it all in respect to x. So x is equal to 4 minus 4y squared. We take square root. All right. This one doesn't look too bad either. This time we want the integral from 0 to 2. And again, it's still symmetric. Even if we rotate it across x equals 2, the top half and bottom half are still symmetric. So this time we get an actual donut just without a hole. And we want to take... Let's see, we actually want this entire cross section. So we have 2 minus, or 2 plus 4 minus 4y squared minus 2 minus 4y squared dy. And let's toss that into the calculator as well. Looks correct. Oh, did I type something wrong again? Because this looks ugly. There's even an I involved, so that's definitely not right. Oh, I see the problem. It's an ellipse. Up here, when we're perpendicular to y, this shouldn't be 2, this should be 1. Because it's only 0 to 1 on the y-axis. So if we toss in a 1 instead of a 2, it should give us an actual answer. The answer is exactly the same as the other question. 78.95684. That's actually surprising. We rotate the shape 2 different ways, then it gives us the same volume. That's pretty cool. All right. Up next, what have we got next here? Ooh, next is 48. This is a unique question. We get a shape. We get our sawed off cone. Looks kind of like pudding. This is such a terrible drawing. This is our big radius r. This is our small radius lowercase r. And then we have our height, which is h. And we need to find the volume. Okay. First thing I want to do is draw a graph. And actually, I know that we have a trapezoid shape here. I'm actually make this easier for myself. I'm gonna say I'm gonna say this is big radius. And this is small radius. And then this here is height. Because if we rotate it across the x-axis, it's gonna create this shape, just horizontally. I'm more familiar dealing with x, so I'm gonna just rotate it this way. Now then, we simply need to find the volume using the cross-section. And the cross-sections are actually pretty easy to find because We have a straight line here. It's not even a curve. But we need to find the equation of the line. It's a straight line, so y equals mx plus b. M is going to be small r minus big R divided by h. That's rise over run. It rise by r minus big R, and the run is h. And then put x here, and then the y-intercept is big R. Y-intercept is big R, and now we have that equation. Now we get to algebra. So it goes from pi, and we go from 0 to h, because our x here is h. And our radius is simply our equation here. And we just square this thing. I don't like it already. R minus RH squared plus 2R R minus RH x plus R squared. Okay. A lot of variables, but a lot of these are constants. We're still only dealing with x, so this is not that hard. If we integrate that, we go from 1/3 R minus RH squared. This whole thing is a constant. And then we get x cubed. Hello, lower x. I'm sorry, but I don't have knees. I only have an upper body. I don't even have hands. How am I writing this? And I'm not harming any trees either. Yeah, I'm doing math on a computer where we don't waste any paper. I'm very environmentally friendly. You don't need to take my knees. Anyways, where was I? Oh yeah, plus we get R minus big R over H x squared plus R squared x. I don't know simple multiplication either. I don't know how many dumb errors I made already. I don't know how I'm doing this, but I can't multiply or do any negatives. But this somehow just works. And so all we gotta do is plug in 8 for x. And that grants us 1/3 r minus r h squared h cubed plus r a whole bunch of r's in h squared plus r squared h. Whew. Oh god, what do I do now? Teacher asked me what's 8 times 9. Oh god, what is 8 times 9? 72. Took me so long. I rarely even do any math anymore. I'm way too reliant on the calculator. If you take my calculator away from me, I'm basically kindergarten level math. What, wiggles? Oh, can I have a wiggle? Anyways, if we factor out the h. Oh my god, that is so cute. God. We have a pot. Oh, that's the scene from the cat. The cat emo. Except this time it's Iron Mouse. Oops. Oh god, what did I just click open? Thank you for the wiggles. That refilled my energy. Now I can do more mass with this power. This looks even uglier now. Okay. What if I factor out a 1/3? Or rather... This is not even mass anymore. It's the only number I see right here. This is... Is this English now? All I have are letters. This is just the alphabet. We have Greek characters here. Okay, I think this is how it goes. And... 1/3 of... Ow. Let's factor out the 1/3 so it looks cleaner. So we're left with r squared minus 2rr plus r squared plus 3rr minus 3r squared plus 3r squared. That cancels out nicely. We're left with pi h3 and r squared plus rr plus r squared. Huh. And that will lead us to... pi h3 r plus r squared. I believe that is the answer. Because this is an odd number question, I can't even double check the answer if I want to. Anyways, these are the slightly more fun questions where you don't have to deal with algebra. "49 is the next problem. Please, do I have to draw a sphere? This is the best I can do. Of a cap? With the height h. And the radius of r. Nobody's gonna be able to understand this question. But I can still turn it into a graph. So we have a sphere cap that's going to be rotated about the y-axis. It has a height of h. And this is going to be r. What can I use this information for? Oh, this is r. Because the radius of a sphere, no matter where you point it, it's always going to be on the edge of the sphere or circle. Alright, then I need to write into equations. For equation of a circle, x squared plus y squared is equal to r squared. And let's solve for x. X equals square root of r squared minus y squared. Yeah, we'll do it in regards to y for now. And what do I do? If it's in regards to y, so we can take the integral from r to r minus h. It's going to be pi. And let's see. There should be pretty easy from this point on. R squared minus y squared squared dy. Simplify that. We get r squared minus y squared. The square root and square cancels out. And because r is a constant, this is our integral. Now comes the fun part of having to plug everything in. To plug everything in, we get so this is terrible. R cubed minus 1/3 r cubed minus r squared times r minus h minus 1/3 r minus h cubed. My brain hurts too. And once we do that, we get 2/3 r cubed minus r cubed minus r squared h minus 1/3. If we draw out the pyramid of factorization, we get r cubed minus r squared h plus r h squared. No, 3 minus 3r squared h plus 3rh squared minus h cubed. And that will leave us with r cubed minus r squared h minus 1/3 r cubed plus r squared h plus, no, minus RH squared plus 1/3 h cubed. Some of these will neatly cancel out, and then we'll be left with 2/3 r cubed minus 2/3 r cubed minus RH squared plus 1/3 h cubed. And then that cancels out, and we're left with plus, no need to write the plus, RH squared minus 1/3 h cubed. And oh, almost forgot. So much lag here. Everything is multiplied by pi. Which means now we can have pi h squared r minus 1/3 h. That looks clean enough. All right. Next up is number 51. Which is a pyramid with height h and rectangular base with dimensions b and 2b. Not sure what that means. About to find out. My brain actually doesn't work right now, so I'm gonna have to try to draw out things as I try to understand it. Pyramid. With rectangular base. So this is 2b, this is b. It's got a height of h. And I need to find its volume. Okay, these are those cross sections. Yeah, if we dissect it, cut it into 4 pieces, we get a little corner. This is b and b over 2 in the height. But that still doesn't tell me. This still does not tell me what I want to know. What kind of cross sections would this have? It would have trapezoids. Hang on, is there an equation for volume of a pyramid? Can I chase my way through this? What if I cut it in 2? Let's see, I cut it in two. Now we're left with a square base. Let's B and B. Huh. This is still height. You know, this is what you get when you cut up, is it? I'm having trouble visualizing this in 3D. But if I look at the sideways, I can see an equilateral triangle. Is the length of H and cross section of B. It's pretty similar to the previous two problems, but feels harder. Get 2 here for symmetry. We start from 0 to B. Actually, I'm having a lot of trouble with this. Would it be triangles? Would it be isosceles triangles? My brain just stopped working when it saw these triangles. Trying to imagine what does half a pyramid look like? Okay. I got it. Get a shape looking like this. All goes down to a single point. This is B, this is B. And I just drew it wrong again, didn't I? Where's height? Height would be right here. Right. Oh, no. I'm gonna need a few hints. Let me take a look at the textbook. Now the cross sections would probably be would be squares if I cut it in half. It's actually difficult. Okay. What if I do this? So base looks like that. 2B and B. We take the side view, we got H and 2B. Volume. Volume is lens time width. In which case it would be just 2W squared. And W would be kind of like B. How about we call this H on X, and this is B, this is B. So length, or if we call width, is equal to was bx over h. Yeah, width over b is equal to x over h, so the width is equal to bx over h. And the volume is 2w squared, so it's equal to 2bx over h squared. So we take the integral from 0 to h of 2, let's call bh squared dx. So to h of 2 bh squared x squared. So that's 2 from 0 to h of b, no, 1 over 3 bh squared x cubed. And if we plug in h, that equates to 2 times 1/3 b squared h. And our answer will be 2 over 3 b squared h. Does that match? The answer matches. This is correct. Oh, that took quite a long time. Alright, after 51 comes 55. 55. Oh god. Oh no. Okay, basically we have 9x squared plus 4y squared equals 36. We have an ellipse. Cross sections. Perpendicular to x axis are isosceles right triangles with hypotenuse in the base. So basically we got this ellipse thing that's also got triangles coming out of it. To put that on a graph, the base will be given by 9x squared 1 2 1 2 3. This is going to be the base. It's terrible, I know. And cross section is perpendicular to the x-axis. So our cross sections go this way. If I want to take a look at one of these, let's call this B. We take a look at one of these right triangles. This is B. And this should be B root 2, right? Hang on. Or was it B over root 2? Might be forgetting something. I think that's it. Let me just double check just in case. One more root 2. So yeah. But using symmetry, you could make this easier into a different right triangle with a hypotenuse of B over root 2 and a height of, oh no, divide by root 2 again, B over 2. Is that right? Sounds about right. So single B here. Probably want to solve for y since this is perpendicular to the x-axis. Y is equal to 36 minus 9x squared divided by 4 and square rooted. Come on. Okay. Let's see. So that is going to be our base. Or is it going to be our base divided by 2? this would be base divided by 2. So the area would simply be this thing squared. We square it. Take the derivative. Oh yeah, this goes from 0 to 2. And because symmetry, we had a 2 there. That would end up with about 9 minus 9 over 4 x squared dx from 0 to 2. We take the integral and get 9x minus 3 over 4x cubed. Oh, the lag. Might have drawn too much on the single board. We should have done a separate board for each thing. And we plug things in. Get 2 times 18 minus 6. 2 times 12 is 24. That is number 55. Following number 55, we will have... Actually, it's the last question of the day, or rather of 6.2. 57. Hello, Kilronet. How are you doing? 57 is actually tied with 56. But I can draw a little diagram to try and describe it. So the x-axis and the y-axis. I'm doing fantastic. Of course I'm in pain. I'm doing calculus. Okay. Anyways. Cross sections. Perpendicular to x-axis are squares, which makes our job so much easier. So whereas I should flip this a bit. I should flip this. This is 1, 1. Alright, then let's draw the actual coordinate plane. One, and that means y equals 1 minus x. That means our area is equal to 0 to 1 of 1 minus x squared dx. If we factor that out, we get 1 minus 2x plus x squared dx. Factor that out a bit more, we get x minus x squared plus 1/3 x cubed. So glad you're not doing this. It's a great way to kill some time. But it can get tedious, especially the algebra. Calculus is like 90% algebra. You do the fun stuff and then you start factoring and all the middle school stuff. Oh, trust me, it is horrendous. Just take a look at this. This is how much we have done so far. Hey, geometry more than algebra? Is it the proofs? proofs used to give me a lot of trouble with geometry. Algebra, yeah, you got algebra. You just keep doing the boring stuff over and over. And math guys is just predominantly geometry, the lowest grade. Ah. Oh, now you're doing trick stuff. All the sine and cosine, all that fun stuff. In calculus, you get to do all of them at once. And we're left with 1/3. That was the problem. Well, for one thing, I don't know who named all that stuff. Why did they decide it's a good idea to name them sine, cosine, tangent? Anyways, that concludes 6.2. Moving onwards to 6.3. You memorized? I haven't even memorized all the trig identities. Some of them I just can't remember. Oh, 6.3 is volumes using cylindrical shells. The right triangles. Ah, so Cattell, sine. What's sine opposite hypotenuse? Yeah, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I remember using that. Like on the SAT, I would need to chant it like a summoning ritual to summon the triangular god. But all I really remember for triangles is a squared plus b squared equals c squared for right triangles. I remember there was much more complicated cosine functions to calculate for the sides of non-right angles, but yeah, same. I would not have gotten through trig without knowing that. Volume using cylindrical shell starting at number 5. Now you're doing 36, 63, 90, 45, 45, 90. I remember some of those. For 30, 60, 90, you got x, 2x, x root 3. And then for 45, 45, 90, you got x, x, x root 2. I actually remembered something for once. Number 5 wants the volume of E equals e to the power of negative x squared bound by y equals 0 and x equals 0 and x equals 1 around the y-axis. So I haven't actually learned how to do this yet, but I did read the textbook, which kind of helped. For fun or practice, this is just homework. If I had a choice on what to do with my time, I'd be playing Elden Rings right now. Anyways. e to the power of negative x squared. So that means it's going to be an even function. As x approaches infinity, e approaches 0. As x approaches 0, e approaches 1. So it will look something like this, kind of like this. Did the homework too, but you're procrastinating? Hey, we could do homework together right now. You could probably get over with it pretty fast. I could help you with it. I might not be the smartest kid in the class, but I can still do a couple trig. Rather not. Yeah, I would rather not be doing this either. I haven't slept in what, 3 months? And it's almost 1 o'clock, and I'm still here doing this. I was supposed to be gone like an hour and a half ago. But no, I had to do this. Anyway, for the cylindrical shell method, some primary theorem we call it is 2 pi times radius. I have a 92 in biology. Wow, I hated biology. I was thinking biology a while ago. I remember there was one time that something really funny happened. It was the end of the finals. We were having competition on standing up and answering questions. And it was between my table and another table. And we were pretty much guaranteed the win. Everybody at our table knew their stuff. Enzyme and photosynthesis. Biology is the one class where pretty much nothing I ever learned I will ever need, ever. But anyways, at the very last question, I just stood up and shouted George Washington, and the teacher said we lost. And then we didn't get the extra credit. So after that, all my table mates hated me. And with the height is going to be our vertical line here. And our radius is going to be our x. It's kind of hard to apply biology to real life. Other than the one time we dissected a frog. That was the only time we ever applied biology in real life. But using the cylindrical shell method, I would reach the conclusion that we want the integral from 0 to 1. 2 pi is a constant. So we can just bring 2 pi out of here. I mean, when do you get the chance to dissect a frog? Only your biology class. And we have to take out all of its organs and then identify which one is which. And then we get x times e. X is the radius times e to the power of negative x squared, which is the height. You dissected a goat heart. Whoa. Back then in 5th grade, I don't think they even let people handle sharp objects in the school districts around here. You'd be running around with the safety scissors that are made of plastic. Your school's cool. anyways, if we take the integral... Oh, it wasn't a public school, no wonder. Over here it's all public schools. Yeah, we literally had someone throw up while we were dissecting the frog. And I don't think the smell even came from the frog. I think it comes from the preservatives. Horrendous is a fun word to pronounce. Mine's probably yeet, spelled Y-E-E-T. Whenever I join the call, that's the first thing I say every single time. If we take the yeet, I still don't know what it means, but I think it means throwing something really hard. If we take the integral, we would get something on the sort of negative 1/2 e to the power of negative x squared. Because we take the derivative of that, we get negative 2x, and that cancels out, that's xc negative x squared. It is really cold here now. Now we need to plug in our numbers. We get 2 pi. I don't think it's in any dictionaries either. It's just the words that the internet made up. Yeah, I have negative 1, we get 1 over 2e minus, if x is 0, then e is 1 plus 1/2. Put that together, we get pi times 1 minus 1 over e. Not wondering, I've never actually tried to search define yeet. What does yeet mean? Oh yeah, yeet. Yeet is an exclamation of excitement, approval, surprise, or all-around energy. Often as issued when doing a dance move or throwing something. Let's go. Alright, that was number 5. Followed by number 5, we have number 7. Number 7 says y is equal to x squared. Y is equal to 6x minus 2x squared. And about the y-axis. So funny the way they describe yeet. It does make sense though. It's an exclamation of excitement. When you see your math homework, you take the textbook and go yeet, and it goes to the other end of the room. It's almost magical. Now, if we graph this, okay, we have one weird parabola. They probably want to put into vertex form. To do that, we want to factor out the 2, negative 2 x squared minus 3x. Uh-oh, would be pretty ugly if we do that. So no. Then how about y equals 2x 3 minus x. That means we're gonna have intercept at 3 and 1 0. If we plug in 0.5 and then 1.5, and 0 over 2, we'll get 2 times 0 over 2 squared, 9 over 2. Looks something like this. Stop. Stop. Ah! Can't draw curves. So hard to draw with this thing. Followed by a regular parabola. Now where do they intersect? First off, we're rotating about the y-axis using the cylindrical shell method. Everything's in respect to x, so this is good. X squared minus x squared equals 6x minus 2x squared. So x squared equals 6x, x equals 2. Okay. Knowing that, we can start doing our integral. We want to go from 0 to 2. We put a 2 pi in front, followed by our radius. I do not have a lower body, so I physically cannot do that. Followed by our radius, which is x, and then the height of the shell is going to be the top function, which is 6x minus 2x squared, minus the bottom function, which is x squared. It is very unfortunate, but I gotta live with it. And then dx. There's the height of our shell, radius of our shell. Now we just need to more algebra. Algebra takes so much time. We get x. Oh no, the whiteboard's lagging again. I just take a lot of coffee. Okay, so we got 6x minus 3x squared. Uh-oh, whiteboard's unresponsive again. Might have drawn too much on a single board. Yeah, okay. Why does it keep not working? 2 pi, draw our integral again. So we've got 6x squared minus 3x cubed. Come on. Dx. Cylindrical shell method is actually arguably easier than the cross-section method, if you can use it. So you don't have to square everything. And my god, we had to foil all the square. Takes so much time. Now we take the integral from 0 to 2. That turns into 2x cubed minus 3 over 4 x to the power 4. Well, we got the squiggly mark, which is an integral. It's a weird ritual we perform to numbers in calculus. And then we got the straight line, which just means plug in the top number and subtract the bottom number. So this would be 2 squared minus 1 squared. This is pretty easy to understand. Just plug in the top number and then subtract it, plug in the bottom number. And then of course we have your favorite friend pi here, coming from the Greek alphabet to torture you. Now we plug in 2 into x. We get 2 to the power 4 minus 3 over 4 to the power 4, which grants us 8 pi. And another one. It's not just long, it's infinite. If you keep reading the digits of pi, it can literally kill you. That's why we must never speak of the pi. It's an eldritch ritual. If you keep reading it, you might accidentally summon a demon. Number 9 says x times y equals 1. Still waiting for them to find the last digit of pi. We've already lost so many mathematicians trying to do that. But hey, we already know it's gonna be a digit between 0 and 9. So if we just pick a random one, and we have a 1 in 10 chance of getting it. If it ever ends, that is. What if pi just never ever ends? And we never find the last digit? There has to be a number. What if pi ends in pi? Theoretically, pi will contain every possible combination of numbers. It is the ultimate number. When pi ends, the world ends with it. And we have x times y equals 1. That's basically y equals 1 over x, which means we get this weird thing. X equals 0, y equals 1. So we take this part. Y equals 3, we take this part. And this says about the x-axis. Let me add that in. About the x-axis, that means we rotate it this way. It will come down here and be like that. Now, if we're forced to use the cylindrical shell method, everything needs to be in respect to y, which is pretty easy to do with this problem. We go from 1 to 3 on the y-axis. We put our 2 pi in front because stay organized. Our radius is simply y, and our height is 1 minus, no, it's 1 over x. No, 1 over y, 1 over y, dy. Giving us an incredible 1 dy. Meaning we simply have y. So 3y, so 3 minus 1. Hang on. Is 3 minus 1 times 2, we get 4 pi. Wow. The textbook's throwing all the easy questions at me. If this continues, I might actually be able to sleep. Now for number 11. 11 says y equals x to the power of 3 over 2. Y equals 8. And x equals 0. Now do y times 4. Why do I multiply y by 4? If we graph this, pi times 4. Oh no. That's 12 something. And we just call it 4 pi. I can't remember past the second digit of pi. I just know it's 3.14 and I don't remember the rest. Bro, imagine if someone has memorized all digits of pi. They'd be the most intelligent being in the universe. Oh, 3.14159. You remember 5 digits? I only remember 2. I wonder how much Google remembers. Oh god. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Google knows 11 digits of pi. Google is smart. Imagine your entire grid is based on how many digits of pi you can remember. Anyways, x cubed squared. Oh no. How do I graph this again? Okay, if it's over 2, it's only positive. Probably looks like this. And is that y equals 8? Okay, and this is about the what axis? This is about x-axis. That means we gotta take the integral from 0 to 8. Our radius is simply y. And our height is going to be 8 minus... Hang on. Wait a minute. Our radius is y. Okay, we gotta solve for x. Our radius is y, and then our height is 8 minus y to the power of 2 over 3. And if we simplify that, bam. Now we take the integral. It is very repetitive. You basically do the same thing 10 times over. And that is 3 over 8. Y to the power of 8 over 3. And oh no. This doesn't look too right. Whenever there's a huge number somewhere, it usually means I did something wrong. We'll see. We'll find out. At least have a calculator. 2 pi times 4 times 64. 256 minus calculator 8 to the power of 8 over 3 times 3 divided by 8. 96. Now we have 256 minus 96. 160. Something doesn't look right. Something definitely does not look right. I see. Hang on. No, I don't see. Uh, 嗯 Where did it start going wrong? This is kind of like programming. You spend 5 minutes doing a problem, and then half an hour trying to figure out what you did wrong with it. From 0 to 8. Would give us the integral is wrong. Did I write down the problem wrong? I go x to the power of 0 over 2 about the x-axis, yes. X equals 2 over 3y. Let's try that again. The height is y. Now the radius is y. The height is this thing, which should be y to the power of 2 over 3. Wait a minute, is that what was wrong? I overcomplicated things. Speed things up. And Now what does it give me? 8 to the power of 8 over 3. 96. And we get 192 pi. Is correct. Now then, that was 11. Next up is 13. Says x equals 1 plus y minus 2 squared, and x equals 2. About x-axis. Alright, doesn't look too terrible so far. Draw graph. X equals 1 plus y minus 2 is a horizontal parabola. Starting right here. So it goes like this. And x equals 2 is right here. We want to rotate it about the x-axis. Uh-oh. Why is it loading again? So we want to go from 1 to 3. Because that's 1, 2, 3 on the y-axis. And our radius is y. Our height is 2 minus 1 plus y minus 2 squared. That is long. Too long, so simplified a bit. 2 minus 1. That's 1 minus y minus 2 squared dy. Didn't really help. Probably want to FOIL things out. Y squared minus 4y plus 4 dy. Do even more algebra and we get negative y squared plus 4y minus 3. dy. Do even more algebra and we arrive at negative y cubed minus, no, plus 4y squared minus 3y. Now we can, this is question 13. Take the integral and we get negative 1 over 4 y to the power of 4 plus 4 over 3 y to the power of 3 minus 3 over 2 y to the power of 2. I sure hope I didn't make a stupid mistake somewhere in here. Got 2 pi. Negative 3 to the power of 4 over 4 plus 4 over 3, which is 4 times 3 over the power of 2 minus 3 over 2 times 3 to the power of 2. So everything here can be expressed in 3 to the power of 2. Here we get 9 and 3 to the power of 2. We can factor that later. So minus -1/4 plus 4/3 minus 3/2. Do a little bit of factoring, we get 9 times -9/4 plus 4 minus 3/2. If we put them all in equal terms, we get plus 16/4 minus 6/4. And that goes down to 1/4. We'll write that next. 2 pi times 9/4. Just making sure I didn't do any math wrong. And the minus here is a bit more difficult to put everything in equal terms. Best thing we could do is probably 12. So we get -3/4 plus 16/12. No. -3/12 plus 16/12 minus 18/12. So the number 4 minus, over here we get -3, -21 plus 16, -5/12. We get plus 5/12. Huh. And that does not look right. It is debug time. -3. Wait. I did math wrong again. Or did I? This is all very odd. Let's go through with it first. Plus 5/12. We multiply everything by 2, we get pi times 9/2 plus 5/6. Pi times 32/6. Pi times 16/3. 16 pi/3 is correct. Ooh, getting closer to the finish line. Next up, 13. 13 says x is equal to... Wait, I just did 13. 15. 15 says y is equal to x cubed, y is equal to 8, x is equal to 0, about x equals 3. Now if I graph that, oops, click out of it again. We get our standard cube function. Looks ugly. Stops at y equals 8. And we rotate it about x equals 3. We rotate it about this line. So This is our height. That means we can take the integral from 0 to 2, put the 2 pi in front. Our radius is simply x. Is it? It is. Our height is 8 minus x cubed. And we put dx here. We simplify 8x minus x to the power 4 and take the integral. That leaves us with 0 to 2, 2 pi, and 4x squared minus 1 over 5, x to the power 5. Plug in numbers and we get 16 minus 32 over 5. And if you put 16 over 5 as well, we get what? 48 over 5. And something feels off again. Right. We're rotating about the line x equals 3. Oh, there's a lag again. Click already. It's not clicking. Okay, go from 0 to 2. Height is 3. Hang on. If x is 1, the height should be 0. Huh. I know what I'm doing wrong, but I forgot how to fix it. Radius is 3 minus 8 minus x cubed. Dx. Let's see. If radius is 3, or wait. Oh, I see what I'm doing wrong. The radius is the one that's wrong. It's not the other. So we go from 0 to 2. Our radius is 3 minus x. The height is still 8 minus x cubed. Factor that out, we get from 0 to 2, 2 pi, 24 minus 8x minus 3x cubed plus x to the power 4 dx. Now it looks ugly again. take the integral. Go from 24x minus 4x to the power of 2 minus 3 over 4x to the power of 3 plus 1 over 5x to the power of 5. Now we're talking terrible. We end up with 2 pi times 48 minus 16 minus 6 plus, oh god, 72 over 5. 2 pi times 12 is 22. 26 plus 32 over 5. No. This is to the fourth power. Good thing I realized. And this is minus 12. So we're left with 20 plus 32 over 5. That means we get 2 pi 132 over 5, and we get 264 pi over 5. Fantastic. That was 15. Next up is 17. 17 says y equals 4x minus x squared. Y equals 3 about x equals 1. I've that out. 4x, so that means at 4, and at 2 is 4, goes like that, and y equals 3 would be right here. We rotated about the line x equals 1. Which is right here. So the height is right here. Alright, for this problem, we're rotating about the x-axis. We go from 1 to 3. And put our 2 pi here. Our radius is x minus 1. That should be right? This one is 3 minus x. Is it plus or minus? Should be minus. And our height is 4x minus x squared minus 3 dx. And if we factor that out, oh no, we get 4x squared minus x cubed minus 3x minus 4x plus x squared plus 3. combine like terms, and you get 5x squared minus x cubed minus 7x plus 3. There has to be at least one negative sign that's wrong here. I can already feel it. The x. Alright. If you take the integral, we get 5 over 3x cubed minus 1 over 4x to the power 4 minus 7 over 2x squared plus 3. Now we get to plug everything in. Get 45 minus let's do this a smart way. Take out 3 first. 15 minus 27 over 4 minus 21 over 2 plus 1 minus 5 over 3 minus 1 over 4 minus 7 over 2 plus 3. Oh no, this is gonna be terrible. I can already feel it. Alright. Get 2 pi times 3 times what? If we put them all into 4, get 42. 42 plus 27. 69. 69 over 4. Minus 5 over 3 minus 15 over 4 plus 3. Three times 16. 48 minus I'll write 3 times 16 over 4. Don't want to calculate. Have a lonely 3 right there, but that's fine. For 5 minus no plus 15 over 4 minus 3. And if we try to combine, let's calculate this. $307 over 4 plus 15 so 222 over 4. That's not divisible by 4, but it is by 2. So let's say $111 over 2 minus 5 over 3 minus 3. Simplify that again, we get 45 minus... Can we take out 45 from here? 21 over 2. Take out the 45. Minus 5 over 3. Divided by 2, we get pi times 21 minus 10 over 3. Get pi times 63 over 3 minus 10 over 3. Get 53 over 3 pi? No. That is most definitely not it. Something is wrong. Time to figure out what. Christoph, is my integral correct? And hang on. Should be 8 pi over 3. So the integral should give me 4 over 3. The integral is correct. If the integral is correct, then I messed up the algebra somewhere again. Where did I mess that up? It was correct up to here as well. Perhaps it was this. It is definitely just an algebra problem. Let's try this. 48 minus 3 times 69 divided by 4 minus 5 over 3 plus 50 over 4 minus 3. Seems like this is where it started going wrong. So this is not it. Where does a problem arise? It's 3 times 15 minus 27 over 4 minus 21 over 2 plus 1. I should have just used the calculator from the start instead of trying to do all this by hand. Would be so much faster. So starting from this step, everything's wrong. Did I integrate correctly? I see. I forgot to put an X here. Can't believe that happened. Okay, we can still fix this. Actually, it would be easier to just do it over. Let's see, 2 pi we can factor out 9. 9 times 5 minus 9 over 4 minus 7 over 2 plus 1 minus 5 over 3 minus 1 over 4 minus 7 over 2 plus 3. That looks better. Get 9 times 6 minus 23 over 4 minus 5 over 3 minus 15 over 4, right? Plus 3. Okay, that means we get 2 pi times 9 times 6. Cat awakens. Ow. Minus 9 times 23 over 4 minus 5 over 3 plus 15 over 4 minus 3. I think it's time for the calculator again. 9 times 23 minus 15. Ooh, we get a nice number. 2 pi 9 times 6. Let's just call it 45. Wait, no. I'm messing up my multiplication tables. 192 divided by 4 is 48. Minus 3. So this is 2 pi times 3 minus 5 over 3. 2 pi times, hang on, 4 over 3. We get 8 pi over 3. And that is correct. Nineteen says x is equal to 2y squared. Y is greater than or equal to 0. And x is equal to 2. About y. No, about y equals 2. And let's graph it first. X equals 2y squared. That's just a weird stretched horizontal parabola. Y is going to be greater than 0, so it's only the top half. And x is equal to 2, so it stops at 2, 1. We rotate about y equals to 2, so we'll rotate across this line. But I feel like I forgot something somewhere. There it is. Did I forget it anywhere else? This one too. Okay, just draw little spirals. Oh my god, this thing's really lagging now. Sure hope it doesn't crash on me. Wait, where are we? I didn't move anything around, right? I'm afraid I might have accidentally dragged something and it's just gone. Alright, continue with our problem. Our height is here. That means, because we're going about y equals 2, we're doing with respect to y. So we go from 0 to 1, 2 pi here. Our radius is 2 minus y. And our height is 2 minus 2y to the power of 2 dy. Factor that out. We get 4 minus 2y minus 4y squared plus 2y cubed dy. Now we take the integral 4y minus y squared minus 4 over 3y cubed plus 1 over 2y to the power of 4. Plug in number and we get 4 minus 1 minus 4 over 3 plus 1 over 2. Check the relevance of the answer. Looks to be on the right track. So if we just multiply the 2 in, we get 6 minus 8 over 3 plus 1 pi times 7 minus 8 over 3. So 7 times 3, 21 minus 8, 13. Because 13 pi over 3 is correct. We are almost there. Following 19, we must complete number 23. Number 23 says y equals cosine. Uh-oh. Let's zoom in a little so I can write better. Y equals cosine x to the power of 4. Y equals negative cosine x to the power of 4. X is between negative pi over 2 and pi over 2. And we rotate about x equals pi. So this is the most confusing question I've seen so far. I've already have no idea how to graph it. So let's say this is x equals pi. This is pi over 2, pi over 2. Cosine of 1 is, the cosine of 0 is 1. So that means this is a 1 here. It will go down, but because it's to the power of 4, it doesn't fully go down. Looks like that. And we rotate it around x equals pi. Okay, we can use a little bit of symmetry here. So instead of 2 pi, we got 4 pi. We go from negative pi. Actually, let's get our height right first. Our height is here. Like pi over 2 to pi over 2. Right. Our radius is pi minus x. Our height is cosine to the power 4x. I hate this already. And dx. I don't know if I'll remember how to integrate this. Wait, no, we can use a calculator. We're allowed to use a calculator. Okay. We just need the integral. We only need to set up the integral and then just use a calculator. Oh, yes, I don't have to solve this by hand. Thank God. I would have gone mad if I had to solve this by hand. Alright, let's see. What is our answer, calculator? Times 4 pi. Calculator says it is 46.509 42 with a bit of rounding. I love these problems. I don't have to solve any algebra. Following that, we need to do our number 25. Number 25 says x is equal to sine 1, y is between 0 and pi, x equals 0, about y equals 4. Draw graph. Just a rough sketch. Square root of sine. How would that work? How does the square root of sine work? Let's see. Okay, if it's y equals square root of sine x, then sine of pi is equal to 0. Sine 0 is equal to 0. Graph will look like this. A flat circle. No, a flat semicircle. And to solve this, we would use the equation go from 0 to pi. We revolve around y equals 4, which is just above this, which should be pi. So radius is 4 minus x, or height is... Wait, no, not x, not x. Y. Our height is square root of sine y. And thank God I do not need to solve this by hand. Alright. Into the calculator it goes. From 0 to pi. Okay. No antiderivatives found. But it still gave me an approximation. So what if we multiplied that by 2 pi? Huh. That's strange. Let's try x. Wait. Times 2. Oh, I forgot to type a 2 in there. So we get 36.57476. Again, rounded up. And that is correct. Following 25, we arrive at 37. 37 says y equals negative x squared plus 6x minus 8. Y equals 0 about y-axis. And it also says you're allowed to use any method to find the volume, whether that's by cross-section or cylindrical shell. So we'll find out which one would be easier to deal with. And no. Vertex form. Y equals has to be negative. Let's complete the square. That turns out to be 9. Negative x minus 3. Squared plus what? Plus or minus 1. Plus what? Plus what? So it starts at x equals 3 and y equals 1 and goes down like that. Y equals 0 and rotate about the y-axis. That means it would be a lot easier to do cylindrical shell. Therefore, I'm going to do a cylindrical shell. we go from 2 to 4 because that's 2. That's going to have to be 4. Right, yeah. And put 2 pi there. Our radius is simply x because we start from the y-axis. And our height is going to be negative x squared plus 6x minus 8 dx. Simplify that. We get negative x cubed plus 6x squared minus 8x dx. Now we can integrate from 2 to 4, 2 pi times that, negative 1 over 4 x to the power of 4 plus 2x to the power of 3 minus 4x to the squared. Now then, we simply need to plug in numbers. Oops. 2 pi times negative 4 cubed plus 2 times 4 cubed minus 4 cubed. That cancels out perfectly. So we just left with 2 negative 2 squared plus 4 times 2 squared minus 4 times 2 squared. And no, did I do it right? Feels like I missed something. You know, that's fine. That cancels out beautifully. We're left with negative 2 squared. So 2, 4, we're left with 8 pi. And after number 37 is done, we arrived at the final problem, number 39. Which is to say that y squared minus x squared equals 1. We have a hyperbola. Y equals 2 about the x-axis. Now then, let's graph this. Oops, wrong color. Kind of unresponsive when I do undo. It kind of stacks up and suddenly undoes 10 different things at once. Now then, this hyperbola, it's got the standard. It's y minus x, so it opens upwards and downwards. Meets at 1. And goes like this. And this. Looks kind of like a basketball. And we cut it off at y equals 2. Rotate it about the x-axis. We could do both cylindrical shell or just cross sections here. What would be easier? Feel like for this particular one, cross section would be a lot easier. So let's try cross section. I know symmetry, the left and right are the same. So we can do 2 pi. We go from 0 to y equals 2. So you're gonna meet at, what is this? Go. Square root 3. Plug in 2 for y, solve for x, you get square root 3. And then we get 2 squared. That's our outer radius minus inner radius, which is solve for y equals 1 plus x squared square root. This is why I thought it would be easier to do this, because you square it, it turns right back. Dx. Can do it with respect to x. Another reason was because I didn't want to deal with y. Uh-oh. Oh no. Haven't done the wrong color for all this. Blue. Ooh, I can't have light blue. This also needs to be blue. Let's make this thing blue as well. Oops, close out of that again. I'll draw over it with a bit of black so you know this is the axis. Fantastic, I made it look even uglier. Alright. Simplify. 4 minus 1 minus x squared dx. So we simply have 3 minus x squared. I like easy to deal with numbers. Now we integrate. Goes to 3x minus 1 over 3x cubed. And plug in number 2 pi times 3 root x, no, 3 root 3 minus root 3. And then we're left with 4 pi root 3. And that is where's 39? That is correct. Fantastic. That concludes this section, or what should we call? That concludes this episode of Experience of Suffering Calculus Edition. Chapter 1 through, no, chapter 6.1 through 6.3. All right. Now let's put on some music because it's Saturday, or rather it's Sunday now, but I still want to do my velocity devlog. So let me find my music. Let's see. Too loud. Alright, let me get the server up and running. And it's running. Now I just need Minecraft running too. My god, this is absolutely running horrendously slow. I started saying horrendously too. Lag. I have way too many things running simultaneously. And Chapter 1. Let me reset my viewpoint. There we go. Seems to drift slightly over time. And alright, this is what I wanted to show off. Give me a sec. Alright, music can stop now. I go to gameplay. And here's Minecraft. It's going full screen. So ever since last time I finished working on the PSI and the service pistol. Service pistol is my favorite weapon. It's just so fun to use. I've been working on a new melee weapon. The Templar Sphere is going to be the first melee weapon. And rather than just boringly punching something in Minecraft like you do in vanilla, this one has actually animated attacks. Now, currently this goes around full circle. It could just go maybe 90-degree angle in front of you. But it'll basically do a sweep attack and hit everything in front of you. I've been trying to experiment with different ways to making that work. The math that I put into this is so much harder than the calculus homework I just did. This thing took me so long to get right. Because in Minecraft, you have a pitch and a yell. You don't have a roll. Actually, no, that's not really the problem. It just took a lot of math. It took a lot of math to get that working. And there's also ones that didn't work so well. Oh yeah, if you hit the ground, it kind of pops out. Which... Here are some things that didn't work so well, but still looked kind of cool, so I decided to keep in it for now. There's no pattern to where this hits. All I know is it looks kind of cool. I don't even know how the mask on this thing works. I just know how this one works. There probably is some already built into Java library for rotation. I probably just reinvented the entire wheel here. But damn, This also looks very cool. All the lore stuff are still heavily in progress. The sphere is gonna be mainly slash and heat based, with a special variance that's gonna be dropped from a boss that's gonna be impact based. But that's pretty much all I have for today's Velocity devlog. Unfortunately, school started, don't have nearly as much time to work on my hobbies. So, can't believe it's already been 5 hours. Time passes so fast when you're doing math. Wait, no, it's been 5 hours. Time passes so fast when you're doing math. Thank you everybody here from the future for watching, and I'll see you on Monday when we go back to playing Lobotomy Corporation.